This is the GCSE Higher Revision on Trigonometry. Now this video is only going to focus on right angle triangles, which is grade B, and the next video will be on non-right angle triangles using trigonometry and finding the area of non-right angle triangles, which goes into grade A and A star. So, before we start, I'd just like to remind you that on the Durham Learning Gateway, if you go to the student side, GCSE past papers, and go GCSE by topic, there's a list of trigonometry questions which looks just like a past paper. And it's all the questions that have come up in past papers, all about trig. So that's a good place to start your revision after this video. Okay, so firstly, just to start, a quick recap of Pythagoras. Now, Pythagoras' theorem is grade C, and we should all know that. It states that there's a link between the three sides of a right angle triangle. If you do the smallest two squared and added together, it should be the same as the hypotenuse squared, or a squared plus b squared equals c squared. And that's the same for any right angle triangle. Now, the only difference about trigonometry is that all it says is that there's also a link between the angles and the sides in a right angle triangle. And those links are based on the three trig functions: sine, cos, and tan. So the first thing is that there's a link between the angle, the side opposite it, and the hypotenuse. And that link is that if you do sine x in your calculator, so sine of your angle, that should be the same as the answer when you do the opposite divided by the hypotenuse. So let's just choose an angle of 53.13. Now, this is one that I've worked out earlier. So if I did sine of 53.13, I get 0.7999999. So sine 53.13 equals 0.79999, or 0.8 when you round it. Now I know that that would be the same in a triangle which had a length of 4 centimeters here, and the hypotenuse was 5 centimeters. Because 4 divided by 5 would also be 0.8. This would be 3 centimeters. So that's a triangle that I know myself. If we wanted to link between the adjacent and the hypotenuse, we would use cos x. So let's try cos of 53.13. Cos 53.13 equals 0.6. Cos 53.13 equals 0.6. And 3 divided by 5 is also 0.6. The final one then, tan x, tan of 53.13 should be 4 divided by 3. Well, 4 over 3 is 1 1/3. So tan of 53.13, 1.3 recurrent basically. It's because I've rounded the angle. But yeah, so that's the links. And that's something that you've got to learn. It's not in the booklet. It's just something you've got to remember. This little bit down here, though, is something that can help you remember. A lot of people make up poems or words or whatever beginning with S-O-H-C-A-H-T-O-A, because that's the order they can remember them in. So sine of the angle is the opposite divided by the hypotenuse. Cos of the angle is adjacent divided by hypotenuse, and tan of the angle is the opposite over the adjacent. SOHCAHTOA is the way you remember the first letters. So that's something you're going to need to remember. If you can get that, you should be able to answer any question. Let's look at a question you could get then. So, question 1 on the left-hand side says find the length x. Well, in any question, you'll be working with 3 pieces of information. Your first job is to work out what those pieces are. Well, we know that we're working with an angle here. We've got 2 sides, and we need to know which sides they are. The first one is the adjacent, because it's the side touching the angle. And the other one is the hypotenuse, because it's the longest side, opposite the right angle. So to find the length x, we need to know, right, well, what's the length between the angle, the adjacent, and hypotenuse? And that one was cos x. Cos x equals adjacent over hypotenuse. Once we know that, we write it down, because you can get marks for knowing which trig function you had to use. All we then need to do is fill in the values that we know. Well, x is 40, so cos of 40 should be equal to the length x divided by 10, adjacent over hypotenuse. Let's find out what cos of 40 is. So cos 40 equals 0.766. 0.766. That should be equal to x over 10. Well, now to work out the angle, we can just do some rearranging of the equation. If we times it by 10, 0.766 times 10 should give us our length x. So length x should be 7.66 centimeters. And that is it, done. Okay, so let's just quick recap. We worked out whether we're using sine, cos, or tan, and we wrote that down, the equation. We then substituted in our values that we knew. We then rearranged and solved it to find out what the missing value was. Question 2. If we look at this one, we've got, again, 3 pieces of information, an angle and 2 sides. And we're going to work out this side. So the angle is 30 degrees. We have the side opposite the angle this time, and also the side adjacent to the angle. And using our SOHCAHTOA, SOHCAHTOA, SOHCAHTOA says that the opposite and the adjacent are linked with tan. So we write down tan of our angle equals opposite over adjacent. Next thing we need to do, substitute in the values. So tan 30 degrees equals our opposite, which is 5 centimeters, divided by the length y, which we don't yet know. This one's slightly different because up to here it's exactly the same. The only thing is the rearranging and solving slightly trickier because the unknown value is on the bottom. The first thing we're going to do is work out what tan of 30 is. Tan 30 equals 0.577. So 0.577 equals 5 divided by y. Well, because the unknown's on the bottom, I'm going to multiply up, just like I did with the 10 here. So it should be 0.577 multiplied by y should equal 5. So then to get y, I'm going to have to do 5 divided by 0.577. Y divided by 5 divided by 0.577, 5 divided by 0.577 is 8.67 to 3 significant figures, centimeters. And that is that question done. Now, if you can follow those 2 steps and work out those, then that's pretty simple, straightforward worked examples of how to work out a missing length. The next thing that we need to talk about is what about when the 2 pieces of information you're given are the lengths and you need to work out the angle. It's kind of like working in reverse, and working in reverse is called the inverse. So using the inverse trig, just like the opposite of multiplying is dividing, the opposite, you cannot divide by tan. It doesn't work. So the opposite of pressing tan of, say, 60 degrees would be that answer, or cos of 60 degrees would be 0.5. If we wanted to do the inverse, we would do 0.5 divided by cos, but that doesn't work. So the inverse of cos, we do shift and then press the button above cos, which is cos to the minus 1. That means the inverse of cos of 0.5, and that should get us back to 60 degrees. So sine of 45 is that number. Inverse sine of that answer should get us back to 45. And it does. So that's what we need to do to work in reverse. Here's an example of this one. Again, we've got 3 pieces of information. We've got the angle, the opposite side, write that on, and the adjacent. We need to think of which rule we're going to use then. Well, opposite and adjacent I know is tan. So tan x equals opposite over adjacent. Fill in the values I know. Tan x equals 4 over 7. And we can work that out. 4 divided by 7 equals 0.571. So tan x equals 0.571. So now that we know that tan x is that, we need to find out what x is by doing the inverse. And all we do is press inverse tan of that answer, 0.571. Inverse tan of 0.571 is 29.726 degrees. Or we can round that 29.7 degrees to 1 decimal place. And that is as straightforward as it is. You just work out which rule you're going to use, fill in the values you know, simplify it down, and then do the inverse of whichever trig function. And that's it. So the hardest type of question you're going to get is one where it combines a couple of things together. In this question, you're asked to work out the length CD. Well, CD is this length here, We've got 3 pieces of information, but they're on separate triangles, so we need to do something else first. We've got an angle here, and we need to work out CD. We'll call that the length y. So we've got an angle, we've got one length, we need another length. Right, I don't have this length or this one, but using this triangle, I can work out this length here, which I'll call x. And I can work that out using Pythagoras. So 3 squared plus x squared should equal 10 squared. So if I work that out, 9 plus x squared should equal 100. X squared should equal 91. So x equals the square root of 91, which is 9.539. 9.539 centimeters. Write that in, 9.539. I now have an angle and 2 lengths to work with. It's the opposite length, and it's the hypotenuse. So I'm going to use sine theta. Sine theta equals, or sine x, theta being the angle just, equals opposite over hyp. So sine 40 equals 9.539 divided by y. And I can work out what sine of 40 is. Sine 40 equals, so 0.643 equals 9.539 divided by y. Times up by y, then divide by the other one. Y is going to be 9.539 divided by 0.643, which equals 9.539 divided by answer 14.84 centimeters. And that's the answer for our hypotenuse there. So that's a tricky one, but if you just work through the steps, you should be able to do it no problem.